My name is Boyan, and today we are going to talk about offline application experience. Before I start, let me ask you, how many of you are developers? Is there anyone here who is doing any kind of design, interaction design, or just design in Photoshop maybe, or something like this? There are a couple of you. All right. Because what I want to do today is to go through all the aspects about how we can improve the experience of our applications when we are talking about offline. So we are not going to focus only on the technical part, but also on the experience part, what principles we have to go through that. And although I'm going to focus mostly on the web apps, the same principles are actually true for native mobile apps if we're working with that. We live in a well-connected world. Everyone has here, I assume, a mobile device, a phone, a tablet, or something like this connected to the internet. But that's not enough. We have appliances connected to the internet. Maybe your coffee machine is connected to the internet. Maybe your washing machine is connected there. Or maybe you have one of these fancy buttons on your fridge, so when your milk is over, you can press the button, and then you get a new bottle of milk delivered to your place in a couple of hours. So our world is pretty well connected, and we are all a part of this. This is a map of the internet connection speed worldwide. And as you can see, the northern part of the world is pretty well connected. The connection speed is pretty fast. However, the more we go south, the more things change. So the connection is not that stable. And if you think this is really a big number, a big amount of population living in these areas, and when we design applications which we want to make popular worldwide, then we really have to think about these people living in such areas where the speed are not quite fast. Let's imagine that you're traveling around the world and working as a freelancer maybe, and you've been doing that, probably do know that, let's say, working from Asia could be a challenge because you may find difficulties with finding a place where you have a good connection where you can work from. Sitting in our office here is fine because we are used to have the best setup for us. We have really fast machines, we have a good connection, but moving a bit there, the things change dramatically. But even if we live in the northern part where we can see that the quality of the internet is pretty good, there are still situations where we can have problems. Is there any one of you commuting to your workplace using a train, let's say, or something like this? There are a couple of people doing that. So when you're commuting, let's say, in a train, you could also see that even though you're trying to do some work there, the connection is quite unstable, and it could change once in a while. So the thing that we statistically live in places where the connections are supposed to be good, there are still situations where we may have some problems. Another example could be that if you are at a big festival somewhere, you know, when trying to use your mobile phone, you could also see that when there are so many people at one place, this could also become a challenge for you. Let's take a look at this example that you are sitting in the train and you are writing your report that you have to hand to your boss in a while. And while you're writing this in online tool, online collaboration tool, at some point after writing a couple of pages, you decide to press the save button. And what is happening there is that you see this kind of screen. Because in this very moment, when you decided to save your work, you suddenly lost connection. Maybe you are going through a tunnel or something like this, just a place or an area where the internet connection is missing. And then that annoys you, because you have already spent time working on something and it's suddenly lost. But then you think, hey, I can press the back button of my browser and I will probably go back. And then you press the button of your browser and, well, you see the same picture basically. So now everything is lost. You know that everything is lost, and your time and your effort is lost as well. And this is not cool. These things shouldn't happen. What we want to do is that we want to design applications that can tolerate when the connection is gone or when the connection is unstable, because this situation improves the user experience drastically. So how can we do this? Now, I want to go through a couple of principles. What means to have a good offline experience? What could it be? And one of the first steps is when the internet connection drops, please degrade gracefully. Basically, don't crash my app or don't show me any warnings or whatever. Just show me maybe a message what's happening. So in our example, this is basically an example of something called Google Docs. I guess most of you know it. And what happens there is when you go offline, there is a small icon up there saying that, hey, you're offline, so that you as a user know what is happening. So the application is still there, it's still open in my browser, but I do know now that something has happened with the internet connection. So I can expect that there will be a different experience from now on for me. Give me always access to this content. So basically, content is always mutable. Doesn't matter. I mean, I'm writing my report. It doesn't really change it if I'm online or offline. I'm still writing my report, and the things are there because I have downloaded the content, right? And I'm modifying it right now. So this doesn't really matter again if I have connection or not. So what I expect in this moment is when I get offline, I expect to be able to continue working on my report so that I can basically finish my job, what I started right there. When we do something as users, we expect some feedback, clear feedback from the machine, from the computer. So if I press a button, I expect something to happen, maybe to see a loading indicator or maybe to see a pop-up showing up. Something should happen demonstrating that my action has been accepted. And this is basically a general principles when designing applications. So I expect the application to provide me a clear feedback what is happening when I'm doing anything. So in this example could be while I'm still working, maybe trying to save my stuff, there is a message out there saying, hey, you're offline, but don't worry, we have saved your work offline. So you don't have to worry because your things are not lost. And this is feedback that makes me feel safe as a user, so that I know that everything that I have spent, all my time and effort, they are saved. The content is always there, and I have opened it, so I have it. So please give me constant access to it, because I care about this. So if I have already opened this application, and let's say that suddenly my browser crashes, or maybe your Windows has decided to install updates unpredictably, and you have to restart your machine, well, I do expect that when I open the tab, I should be able to see my report as it was there, instead of just showing a blank screen or anything else. So because I have opened it, and I have used it, I have seen it, it was there. So I do expect it to be there even if I start the application again without internet connection. When we are using an application, we as users are basically moving from path A to path B. So we are navigating and doing some stuff. And what we want is to be able to go to the last thing we have done. So if I close the application and start again, so please take me to the last step where I've been there. So in my case, let's say that I've been working on page 10 in my report. If something happens and I have to go there again, please show me that I've been working on page 10 and everything is fine with the data I have written there. So these are just some of the principles of what it means to have a good application design when it considered to the availability of the internet connection. There are many others that could be implemented as well. So now we have to think how having these principles, what does it mean? How do we go on with that as a developer? Because most of us here in this room are developers, so we want to see how we can take it to the next step. And the first thing we have to do is we have to go back and revisit what is called the request-response model. What does it mean? Well, let's say that we have a mobile application that is listing some news, and you have the possibility to mark news as favorite. Very, very simple. So what you go there, the typical request-response model will be implemented like this. You go there, you click on this circle to the news that you want to mark as a favorite. What may be happening is probably you get some waiting indicator showing that, hey, I'm updating your stuff. So what is happening right now is a request is sent to the network, then we are awaiting a reply, and then when we get the reply, we are delivering a status to the user saying that, okay, I have now marked this item as favorite so that I know that my action is implemented. What is happening here? There are a few drawbacks with this model. The first thing is that it only works when you are online. So basically, if you are offline, it doesn't work because you can't make connection to the internet, and what would normally happen is that you would get probably an error message saying, sorry, you don't have connection to that. Another issue is that even if you have internet connection, experience really varies based on the quality of that connection. If you have really good internet connection, you basically see a blinking of this model dialog, right? So it will just come up for a millisecond and just disappear right away because the request will be executed quite quickly. On the other side, if the connection is very poor, it will stay there for a long time. And some people will decide, all right, I would expect that most of my users have good connection, so I don't show the model dialog at all. I just freeze the application because I don't expect it to be frozen for a long time. And this will work, of course, as long as your internet connection is indeed fast. But if you get in an area where you have poor connection, then the whole application will be frozen for a certain amount of time. And this is not what we want. This is not good user experience. If we have to make a very short architectural description or modular description of this application, it could be something like that. So basically, we have a view out there. We have any kind of a view controller or whatever you can call it. And then we have the network. So basically, every action from the view results in some action that is translated to a request to the network. Then we have the reply back, and the view is updated with the response from the network. How can we improve that? Well, what we could do instead is that, well, what if our actions are always possible? What if we don't need internet connection at all? Let's say that everything we do in our application, it is possible, it could happen. So this would work like this. We have the same application with the same list. When I click on an item, it will get a color visualizing that, hey, I have accepted your action. This is not the final result, but I have accepted your action, and I'm working on that. And in the background, we are going to make the request in the network. So basically, we have accepted the action, but then making the request in the background. And then once the response is back, then we get the final agreement. And of course, if there is no response or if there's no network, then we will still having this mark out there. We can still see that our action is accepted. What is the difference here? Well, the difference is that we don't need internet connection because it will always work like this. How can we do this? Well, let's say that we introduce a model, which is a global model for our application, and the view is always representing what's in our model. So every time we do an action, we update the view, and the view is synchronized with the network once in a while. If there is a network connection available, we do it right away. Otherwise, we do it when we get connected at some point in the future. And this is dramatic change in the thinking, because now our application can be used at any time. Of course, you still need to load the list of news, and if you don't have connection this time, you can't do this. But the next step is really independent of the availability of your connection. We could do even better. Let's imagine that you have the same list, you have marked your item out there, and the item is waiting to be synchronized with the network. Then you maybe open another application, maybe you are looking at your pictures or something like this, and at some point your mobile phone decides to kill the other application because it needs more memory or something like this. Then you open the application again, and you can see that, I'm quite sure that I pressed this button out there. So suddenly, you have missed your action there. So what's happening is that our model wasn't persisted because it was only living within the application. And as the application gets closed, we, of course, lose everything in our model. So what's the solution? Well, we can introduce a persistent model. So what we could do in this case is we can have another module called application logic or something like this, which is the one updating the model. And the model is always persisted out there. So every action results in a change to the model, and at some point, this will be synchronized with the network. And once it is synchronized, the model will be updated again. The difference here is that no matter if you close the application and open it again, you will still be able to see the last state of your application as you have left it out there. And this doesn't really matter what kind of framework you use, or using MVC or MVM or Redux maybe. It doesn't really matter. This is just an idea, a concept, how you can implement this one. Network is our enemy because it is unstable and could be unavailable. Disk is our friend. So it means that everything on this device can be stored there. And if you're doing native mobile applications, this is quite easy because you have access to these things. If you're doing web apps, it could be a bit more tricky, but there are still ways how you can persist data. And this is what we are going to focus on now in a couple of slides. We'll see how actually we can implement persistence and caching as a tool to be able to use when we are developing web applications. The traditional HTTP way of doing things is that you're making a request to some resource, and you know that in the response you can get some special headers indicating how this resource should be cached. And there are different ways how you could do this. The problem with this approach is that it works individually, so it works per resource. But what if you have a different resources that they depend on each other? And what if you are that unlucky that once you get offline, just one of the resources has to be renewed from the server, and you don't have connection this time? So basically, your web application is not going to work just because one of these resources has to be requested from the server again, and you don't have connection. So as long as we're talking about offline, the traditional method of using HTTP headers doesn't really help us that much. Another variation of this is using so-called cookies. And the idea there is that, of course, we can set some key values that we could use between the client and the server. The problem is, of course, the same, that if we want to do something, then we need internet connection for that. And furthermore, we have to send these cookies with every request, although they may only be or be needed for one part of your website or web application. We tried something else in the past. We used Flash or Java applets. They gave us actually this opportunity to store some data locally in your browser. So this was a good opportunity for us to be able to do some caching for our apps. However, nowadays we don't use these third-party plugins for different reasons. What do we use then? Well, we use HTML5 and all the standards and mechanisms that came with it and that are being developed on top of it. So now I want to go through some of these and see what are the pros and cons of these mechanisms and these standards that came with HTML5 and whether we can use them when we want to implement caching and persistence for our web applications. One of the first mechanisms that came, it's called application cache. The idea here is that we have a file called the manifest file, and in this file we could define how and which part of our website is being cached. Then we could also write some rules about exceptions, fallback, etc. So this file has to be loaded with every request on our page. And the thing there is that once you cache the things, these resources that you have defined, they're cached forever. The only way to remove this cache is to basically provide a new version of your manifest file. All the browsers implemented this. So it was implemented on absolutely all the browsers, so quite good browser coverage. The problem is that it was very inflexible. It was very hard to debug what was happening there. And it also could introduce some problems with caching the manifest file itself, which some people tried and saw that it was a very big problem for them. So all these different problems led to this standard become deprecated, basically. So no one is using this nowadays anymore. We're using files over there. We have operating systems where a file structure is one of the basic structures that we know. So then we thought, why don't we use files in the web as well? I mean, we are good at using files. We know how to use them. And this led to the creation of the so-called file system API. And the idea is the same. It's basically a file system sandboxed in your browser, where you could do all the operations that you know with the files. The thing is that this is not the standard, basically, because it was only primarily developed by Google, and it was implemented in Chrome. So using it in other browsers, Safari, Internet Explorer, Mozilla, this wasn't possible out there. So focusing only on one browser vendor is not a really good solution, especially if you want to develop apps that are used worldwide by many users with different settings. Then we came to a very simple concept. What about just a simple key value store? And this is how the web storage was created. Web storage is exactly this, key value string store. So we can put values there, and we can retrieve values there. And they can be saved globally for your domain or just for the session of your users out there. It is also very well implemented in the browsers. It has quite good support. However, it is very simplistic tool. It means that we have to care for everything that we do. So if we want to cache a big object, to persist a big model out there, we have to manually serialize it, maybe as a JSON, and then put it as a string, then deserialize it back. So we have to put a lot of code on top of that so that we can make it a bit more flexible. For simple scenarios, it's perfect, but then once our logic becomes a bit more sophisticated, then it wasn't probably the right tool. So what else could we do? We know databases, we know SQL, so why don't we use SQL in the browser? And that's also another solution that came out there. A Web SQL database allows us to create tables and basically to execute SQL statements in the browser. And it gave us transactions as well. We love transactions, so it was a good tool. The problem was that it kind of didn't really get implemented by the browsers as well, and eventually led to being deprecated as the application cache. Well, if not SQL, then we go to NoSQL, right? So this is what IndexedDB is. IndexedDB is a NoSQL database basically in the browser. So you can create, again, tables, and you can put just JSON object in this table. And this is also really good tool, that a good mechanism that actually got a good support from all the browser vendors, which means that it's a tool that we could use today if we wanted to do something. Opposite of the web storage, using IndexedDB is good for a bit more complex scenarios. But if you want to use very simple ones, then this is probably a bit overkill. So they're kind of on the two sides of the simplicity. Like web storage is for very simple stuff, this is for more complex. But if you have kind of in the middle, maybe you want to use a bit from both of them, or maybe you need some other tool or some other mechanisms how you want to implement cache. And this is what led to service workers. Service workers give us a way to programmatically define what is happening with our resources. All the previous solutions, they were fine if you want to work with data. The problem is that a part of our website are resources that we request from the server. These probably are our JavaScript files, our style sheets, another HTML files. So these are still resources. This is not data. This is something that we have to load using HTML, unless you want to load everything with JavaScript there, because there we could probably do this. But if we are loading the things like resource with HTML using normal HTML tags, we can't do anything about this. We can't implement caching mechanisms that will be usable for offline scenarios right away. And this is something that we could do with service workers. And the reason for that is service workers are intercepted. They are proxy between your browser and the internet. So there we have the possibility with using code to describe what we want to happen with our resources and our data. A simple lifecycle of the service worker looks like this. So we are basically rising different events. And the service worker, the code there that we write is just listening to these events and performing different actions. So basically, we have install event, then we have activated, where we do the what we want to do. At some point, our service worker becomes idle. It can use some messaging to communicate with the browser, or at some point, if there is nothing left to do, it can just terminate. How does it look like? Well, this is how it looks like to register a service worker. So basically, we check if the browser supports service worker, and then we point to a JavaScript file, which will be our implementation of the service worker. And then this file is, of course, downloaded after that. So it's pretty simple, although the code doesn't look very pretty. So on the install event, so what we do, so this is already in the service worker implementation that we have. So we are listening to the install event, and then we want to do something. In this case, what we do is we're using the built-in cache API that comes along with the service workers. We could see that when we are installing the service workers, we are automatically caching these three resources: index.html, our style sheet, and our application JavaScript. We could see that this is the static part of our application, so we want to cache it out there. So this is just putting it into the cache, and we are putting it into the cache forever, basically. Then we can intercept the fetch event, and the fetch event is raised when the browser tries to load a resource out there. So what we could do now is we could intercept these events, and then what we are doing now is, hey, is there anything in the cache matching this resource that you're trying to load? And if yes, then, well, just get it from the cache. Otherwise, just get it from the network as you want to do. So this is a very, very simple example what we could do with the service workers and what I want to do with them. The good thing is that you can see this is JavaScript code, so we have control over everything that is happening between the browser and the network. So we can both intercept data work with data, and we could intercept resource fetching started by the browser. Service workers give us a lot of opportunities, but they have some specifics that we have to be very careful aligned with. They are working only with HTTPS due to security reasons, and they're working in a separate background thread. So the communication with your UI thread is happening using messages, as you saw. So there are events, and you could post messages to the browser and to the UI thread and back to them. One thing that is very important here is know that the service worker could be still possibly working or doing stuff even if you close your browser. So, and this is something that is very powerful in a way, but it could be also very dangerous. And that's why there are still discussions about the security implications of using service workers into the browser right now. So what can we do with these service workers? I just showed one example, but what else could we do? What kind of scenarios we could implement with this? So now I'll just show you a couple of caching strategies that how they can be implemented using service workers and what kind of data we should be using for that scenario. The simplest one is, or basically this is what you get the default one, is the network only. So that means that everything goes passed through your service worker to the network, right? And you want to use this basically for all your non-get requests, right? You don't want to cache a post request or something like this. And you don't want to cache any kind of analytics, maybe Google Analytics that you have, because they're usually making GET requests to an image or another resource there. So you want to let them pass through these events. You don't want to cache them. On the other side, you could do the opposite. You could add cache only. So you could see everything that is in the cache returned only from there. And this was like in the example. Once you get the request, first time you cache it basically forever or until you manually say that this should be replaced with a newer version. And if you think, many applications, they have a kind of static part which rarely changes. And this could be some style sheets, or this could be just general framework that you're using in your web applications. Such things, they are usually reasonably static, or they change very rarely. And you could control how these are cached, of course, if you want this. So in these scenarios, you want to take them always from the cache. Another way is that what we also in the example is that, hey, if on every request we try to get it from the cache, if it's not there, then we do connection to the internet. So this is one of the majority of the requests will be implemented using this strategy, and this is one of the most popular one, right? Then we could do the opposite. We could say that, all right, we try always the internet first, but if it's not working, then we are getting the data from the cache. And what we're doing here is that, all right, if you have connection to the internet, cool, you always get the newest data. But if you happen to be in a situation where you are disconnected, you will be still getting data, though a bit old probably. So in these situations, of course, you should be able to tolerate that some users for a certain amount of time would get some old data. Then variation of this is, then we always get it from basically to the cache, but we also do an internet connection request. So we show the data from the cache, and then we make a request to the internet. Once we get the response, we update the cache with that. And this is used basically in situations where you don't really need the latest version right now, but you want to be closest to the online version that you have out there. So basically, the next request to the same resource will get the updated version right there. And this is useful in situations where these resources don't update it that often. Then we could use something else if we really want to update the version. So we could do the same, but when we get the response from the internet, if we are connected, then we are updating our view right away. And this is useful, for example, if you think about Twitter or Facebook, you have this timeline with events. So what is happening there is that you always see a number of the latest events, and then once you get a new request, so basically you are polling every once in a while, and once you get a new request, a new response from the internet, you're just updating the whole timeline. But of course, if you are not connected, then you'll be still seeing this static list that has been cached recently in your local cache. In other situations, you could do the so-called network and cache race. What does it mean? You could say that, all right, I want to always show the online version of this resource, but I'll give it a timeout. I want to be very fast. So I really want my application to show quickly. So I'll do a try. If you are in a situation where you have fast connection, good. Just show me the resource. Otherwise, just show me the one from the cache. And this is in very interesting pattern that you could use in situations where you want to make sure performance is very vital for your application. And your users will always be getting the newest one, given that they're in scenarios with areas with quality connection. So these are just some of the patterns or strategies, what we could do with service workers, and how we can implement the different caching strategy. The only thing that we have to be careful with is that when we start working with cache, we have to really understand what data, what resources we are caching, because different resource in our application will require different strategy, and it always means when we are showing the newest version to our users. So in some scenarios, you don't really care about the data, but in others, the data is really vital, and you want to make sure that what you show to the users is really important. So this is very important in these scenarios. What else could we do with service workers? Well, the thing that the service worker is working in a background thread gives us one more opportunity. We could actually implement background synchronization, as we talked in the beginning. So, which means that every request that we want to make to the network, we could put in a queue. And this queue can be synchronized with the internet if you have connection. So basically, if you are connected now, it will be executed right away. But if you are not connected, then it will be put in this synchronizing queue, and it will be synchronized a little later. So this is just another model or another way how we can build on the service workers and use their advantage, what they provide us. The question now is it ready? So if we have to take, if we check like on Can I Use, this website where you can see the current status of service workers, you could see that majority of browsers have already implemented service workers. And there are a few, though, that are still waiting. And this is Internet Explorer, basically Microsoft, and we have Apple with the Safari version of that. So there are still browser vendors that are not really considering implementing service workers. And the problem here is the security implication that they get. There are still very active discussions in the community whether that's a good idea to approach it, or there should be another mechanisms how we could implement these benefits that we would normally get with service workers. However, the community really likes them, and this is basically recently from the Apple conference that was a couple of days ago. So you could see the presentation about the new Safari browser and what it can and all the cool features that it has. And these are just a couple of the examples about people asking them if service workers are going to happen, because they are not part of it yet. So the community is there, and they request this service work because this is a very good solution to many of the problems that we have right now with the development. Now I want to finish my talk with discussing some myths in relation to this application experience when we are considering offline scenarios. Because we already saw all different opportunities that we have. We saw different strategies. So these myths are something that we should consider and see what else we could do to solve it and to be more active out there. One of the first myths is that as we see it as developers, we expect that everyone has good internet connection everywhere at every time. And this is not the case. And suddenly, if we start moving from place to place, the things change. And if we want to deliver applications of high quality worldwide, we want to make sure that we understand how our users live, how they use our application, in what scenarios, in what situations they do this, because this could be really vital to the experience that we want to provide them. Then we could see, all right, I mean, everyone has internet connection nowadays. I mean, why should we consider this? However, this is not the case. It could still happen for different reasons that we are offline once in a while. And these situations could be really life-saving. Imagine that you are doing mobile applications for a rescue team in the mountain, let's say, and suddenly they don't have mobile connection anymore there. So of course you can't use communication this way, but you could still do some part of the application that is still usable even though there is no internet connection. We went through a couple of scenarios about how we could cache data, how we can persist data in order to help us deal with offline scenarios, offline situations. However, these implementation strategies, they are not only helpful for offline scenarios. These are only available to help us to improve the user experience. You can imagine that even if you are still online, by changing from request-response model to the synchronization model, you're drastically improving the performance of your users because suddenly they do everything right away instead of waiting to get response from the network. Then we also thought, all right, when we are doing mobile applications, native mobile applications, we have access to everything that our device allows us. However, on the other side, when we are doing web applications, we are depending on what our browser allows us to do. And we may see that many of the standards, they got deprecated because of different reasons, but still there are tools that we can use and there are possibilities. And I'm not mentioning here the whole bunch of JavaScript frameworks out there that are building on IndexedDB or web storage that allows us to be very flexible in the different scenarios that we might want to use this offline persisting mechanism. The only thing that we have to do, or the first thing that we have to do, is basically to switch our mind for thinking that the network is already there. We have to see that our application is isolated. Let's give the best of it to our users. Let's make them capable of accomplishing every single action on their phone, on their mobile device. Thank you so much.